So I have to confess that although I do have some comments about the review process, my main focus today is really on our efforts at ACM to support reproducible experiments in computer science research publications. And I suspect that it was the interest in this latter topic of reproducibility that led my colleagues to sneak me onto this panel about trends in peer review. These are the topics I hope to cover in the next 15 minutes. I'll talk a bit about why there has been no tradition of reproducible experiments in computer science, what's happened to change that, the lessons we're learning, and in particular, I will comment on how these lessons pertain to artifact reviewing, artifacts being data sets, software, videos, and the unique goals of that type of peer review. And then we'll look at our efforts to define standardized terms, represent them with badges in the publications, and integrate the artifacts themselves with the published articles. Note that reproducibility itself is not an agreed upon term. Different meanings are assigned to it, sometimes contradictory, and other terms attempting to specify types of reproducibility are used interchangeably, such as repeatability, replicability, verifiability, reusability, validation, verification. And note, too, that in computer science, the objects of study are frequently the software and the hardware themselves that are used in the experiments rather than the natural phenomena that are studied in the physical sciences. So 2 years ago, ACM assembled a task force on data, software, and reproducibility in publication. And at our very first workshop, several things became immediately apparent. And first, the various communities that were represented on the task force were all trying to solve similar problems of reviewing artifacts. They were working independently in their own subfields. So they did agree to try to coordinate their efforts towards a common solution, even though they recognized there was difficulty due to stark differences. For example, in the types of data, the sorts of algorithms, the languages, the processors, and the computational resources that were commonly used in each subdiscipline for their experiments. And secondly, their efforts at reproducibility were entirely divorced from publication. So they were delighted and they were surprised, and I was surprised that they were surprised to discover that ACM was actually interested in reflecting their efforts at reproducibility in the review process by conveying it to readers in the publications, and even by attempting to enable readers to rerun the experiments for themselves. So at the simplest level, it's just proven extremely difficult to recreate the environment for running an experiment. Extensive documentation by the author is required, and even with this, it has been a common experience for the reviewers to spend several weeks trying to recreate the experimental environment and install the software, only to fail and to give up under the constraints of time and the limits of their own frustration. So though the task force started with a focus on reviewing software and data submissions that accompanied articles, it was clear that the same impediments that were faced by the reviewer would be faced by a reader or a user of the published article, and that solutions for reviewers would therefore serve the end users as well. So the first thing we learned is that it is very early days in terms of reaching a single general publishing solution that enables ubiquitous reproducibility of experimental results. So we need to take very little steps. We need to create publishing incentives and build good enough support tools and services that will get our scientific research community to change its habits. So initially, do not require that reproducibility results be a criterion for accepting the paper. It's much too high a bar right now, and it's infeasible at this point, in part due to reviewer fatigue. Our review system is already stressed to the max due to the volume of submissions. And in particular, the time-intensive labor necessary to reproduce an experiment would just be a showstopper if this were made mandatory. Make artifact reviews optional, but provide benefits, positive motivation for both authors and reviewers. To encourage authors to perform a considerable amount of extra work in preparing artifacts for review. We've provided special branding in the form of badges that get affixed to their papers if they pass. The badges indicate that the associated artifacts have passed some level of review, some defined level. And on the reviewer side, because there's a huge amount of work there as well, the specialized artifact review panels or individual reviewers need to be highlighted and credited. And this is made a lot easier by eliminating the need for reviewer anonymity for this process in conjunction with a specific paper. In addition, the artifact reviewer may publish a short companion paper describing in detail what was uncovered in setting up and rerunning the experiment. So these reviewers not only get credit for a publication by doing this, which motivates them, but they can also be acknowledged on the masthead as an algorithms editor or an artifact editor. And we're following this practice in 4 of our journals now. So we do not require or even favor blind reviewing for artifacts, at least not initially and perhaps never. We found that authors and reviewers need a considerable amount of direct communication to get the experiment set up and running. Though it is possible to create a liaison between the author and the anonymous reviewers, this is not a very efficient method. We separate the paper review and acceptance from the review of the artifact. So failure to successfully install and run the software does not impact the acceptance of the paper, not at this time. And if it fails, we do not badge that failure. So we also allow for different reviewers to handle the paper and to handle the artifact. This is partly because the subject domain expertise that's required for the paper is not always the same as the technical expertise that's required to set up and rerun an experiment. Note that in introducing reproducibility as a regular part of the submission and review process, we're starting with a very, very different set of goals. In enabling experiments to be rerun, we're not trying to prove that the conclusions of the paper are correct. So instead, our goals are to encourage participation in submitting artifacts and getting them reviewed, and to help the community develop habits of documentation and specification that enable experiments to be rerun more easily, and also in that process of reviewing to help the authors improve the documentation of their software and of their experiment. And also to improve the ease of artifact reuse by the end users of the research, and to capture this more structured specification of the experiment in a way that enables automatic display of the artifact itself in our digital library as a primary first-class object, which can be cited, signed a DOI, and linked. And finally, to encourage sharing that by recommending liberal software reuse licenses so others can reuse the artifacts and build on them for further development. And if you look at this set of goals, you'll notice that none of them argue for reviewer anonymity. It's important to develop reproducibility labels with clear definitions. At ACM, we now have evolved a taxonomy of standard badges that differentiate levels of artifact review. And as I mentioned in the beginning, the terminology for reproducibility is not agreed. So every badge we have is now linked to its definition, which displays with that badge when it appears in the PDF. Our badging starts with simple artifact audits by reviewers. So at this level, there are two badges, artifact evaluation badges, which indicate that the artifacts have found to be either minimally functional or, in fact, easily reusable. The next two badges indicate that not only are the artifacts reusable, but that the same results that are reported in the paper were obtained by the reviewer. So these two badges are labeled results replicated if the results were obtained using those same artifacts. And they're called results reproduced if they were independently obtained without the artifacts in a separate study. And I think that it's worth noting that this is the commonly understood sense of reproducible, that is, the sense of being scientifically validated by an independent study. Okay, so here are, in fact, the badges. As you can see, the large ones are affixed to the article PDF. The small ones will appear with the corresponding colors will appear with citations and table of contents and search results, and their definitions will pop up on hovering. And you note at the bottom, the last badge is artifacts available. So while we encourage artifact sharing, we do recognize proprietary interest in both software and in data. Requiring user access to the artifacts will be a showstopper in some cases. But when the author does agree to grant permission for publication of the artifact, we have to be prepared both to serve it to the readers and at the same time prepared to link to external repositories, because as I mentioned, the most difficult aspect of rerunning experiments is the recreation of the original setup. So tools are emerging to help authors encapsulate their software in lightweight virtual machines. It seems to us highly unlikely that publishers will provide virtual machines and the computational resources that are needed. So we therefore think it's imperative to integrate with these specialized software curation platforms and data repositories that provide these specialized services. Could you just click on the title there, three examples? So in the ACM Digital Library, there's a whole section on reproducibility of results. That is open. You're free to go and look at it. And under a small grant from the Sloan Foundation, we built pilot integrations of 3 external platforms with their corresponding articles in the ACM Digital Library. And we made 3 short videos of each of these integrations. They're 3 to 4 minutes each, and you can see what these platforms are providing as they're integrated in the digital library. And if you would just click on, I'll be done in 1 minute. If you would just click on, say, the pilot demo 3 there. So one thing I want you to look at this page. It looks like a normal article citation landing page, but it's actually an artifact landing page. And the artifact in this case is a standalone video. It has its own DOI, its own metadata. It is not a supplement to an article. And although it does have a definite relationship to a specific article in the digital library. So if I could just, we could go back to the, get out of this and go back to the presentation for the summary. So we've learned to have clear definitions and labels, motivate authors and reviewers with carrots, not sticks, standardize artifact metadata, and use that metadata to identify, cite, and link artifacts as first-class objects, and encourage the sharing of these artifacts by promoting unrestricted user licenses, and integrate external software and data repositories with your publishing platform. So please feel free to go to dl.acm.org/reproducibility.cfm. All this stuff is open. You can look at the videos. You can see the policies that we've evolved. They're freely available to the world. And there's also a link there to a survey about incorporating artifacts in publication. And if you're interested, feel free to take it. Thank you.